Hi, my name is Chris Jones. I'm a computer science teacher at a high school in Virginia. My students will be doing a project soon using a famous Java software package called Robocode. This project will be really fun, and I'm excited to get started in my class. As I was planning, I noticed that a lot of the documentation was challenging to follow and a little bit outdated. So I'm making this video for my students to help them understand and get started using the Robocode software. We're specifically going to set up the IDE Visual Studio Code, which is the most popular editor at the time that I'm filming this video. So I hope that if you are one of my students, this will be a helpful video for you. And if you're not one of my students, you might find some value here as well. Throughout this video, I'm going to introduce what Robocode is and how to get it set up. And to do this, I'm using some slides that I've adapted from a professor in the UK who posted his slides online. I did not ask for permission before using these slides, so I hope that's okay. So let's start with what Robocode is. Robocode is a tank simulation battle game where you write Java code that autonomously controls a robot. So once the battle starts, you're not doing any live controlling. It's all AI type code that you've written ahead of time. The code is very easy and accessible and fun to write, and it's a very open-ended exploration of strategies. So your code controls a tiny robot tank that's driving around the screen. You can drive it around and change its position and orientation. It also has weapons. It has a gun that can shoot, and sometimes you'll choose to ram into your opponent as well. This is, I didn't write any of this code. This is a very popular software package that's been around for a long time. And there's a lot of really exciting documentation and history available online about it. I'll show an example battle in a few minutes. In my class, I'm making this a tournament. If you are just doing this for fun, you can ignore these parts. So let's start with how to get the code on your own computer. So I'm going to switch windows over here. I'm logged into a separate account, but on my professional GitHub account, which is Mr. Jones APS, I've made a fork of the Robocode project. So the Robocode project is very popular and has an official code base that you can download from their website. I made a copy of it for a couple of reasons. The main one is that I had a lot of trouble getting the code to run in VS Code. I had to make a few small modifications, and I thought it would be helpful to publish a version for my students that I know will work well. So for this video, we're going to start with my sample Robocode code. And if you are logged into your own GitHub account, so I'm going to assume for this video, you have a GitHub account, you're able to log into it, and you've also already installed VS Code. So if you do not know any of that, this would be a good time to pause and go get all that set up. If you have a GitHub account and you are logged into GitHub, you can navigate to my version of the Robocode. So github.com/mrjonesaps/robocode, and then you'll want to click this button called fork. So the understanding of GitHub is outside of the scope of this video, but to quickly summarize, forking is a very important concept in the world of software. When somebody makes a large repository of code that they can share with you, and you want to make your own version without modifying theirs, we call that forking their repository. So the way this is going to work is you're going to make a fork of my repository that gives you your own copy of the code that you can play with. So we will click this button. You can ignore everything else that's here and then click this green button that says Create Fork. You will know that this has worked. It takes a minute to work, but you'll know that it's worked when you get to a new window that is called Robocode, and it says forked from Mr. Jones APS/Robocode. So at this point, you have a full copy of my code and all of the different setup stuff that I've included in it. From here, we're going to switch to Visual Studio Code, which I've already got open in the background. When you first launch Visual Studio Code, if you already have GitHub installed and the GitHub plugin, you should see this thing that says Clone Git Repository. If you don't see that, it's likely that you don't have Git on your computer. And if you're working on a Mac, then it is often not installed by default. You can solve that by opening a new terminal. I went to Terminal at the top and then New Terminal, and then just type Git. If you get a message that looks like this, then you have Git and you should be good to go. If instead you get a pop-up that says you need to install command line developer tools, you'll need to pause this video and go follow the instructions to do that. It's a pretty painless process. So if you have this button that says Clone Git Repository, you will click here and you'll get a box at the top that says Clone from GitHub. And at this point, if you are not logged in to Visual Studio Code with your GitHub account, you'll have to take a few extra steps. So right now I see a list of all of my GitHub projects. If you don't see a list of GitHub projects, you'll see something that says sign in with GitHub. It'll take you to GitHub to sign in and validate sharing your credentials back with VS Code and all that. Eventually, you should get to the point where you see an option. This should be sorted by time. So this is the most recent GitHub project that I've created is the fork of Robocode. So I'll open this. And the next thing it's going to do is ask you where you want to save your file. I'm going to put it on my desktop. That'll make it easy to find later. So then I click select as repository destination. And then it'll ask if I want to open it. Yes. And it will ask if I trust the authors. And maybe it won't. Okay, you might get a pop-up here that says, do you trust the authors of these files? And I guess that's on you, but you should certainly say yes. Getting this running is a little bit tricky. So the best way that I know is to go into the folder called robots and expand any of the subfolders and open any of the Java files, and then click this play button in the top right of the screen. When you do that, you might get a little pop-up that asks if you want to run compiler test. Sometimes that's helpful. This will make sure you have Java set up on your computer. If it says compiler operational, then that's great. The next thing I do is on the left-hand side here, click Run and Debug. And you should see a debugging profile called Robocode. So you can click Play next to that. When you do this, what it should do is automatically compile any Java files that are included here, and then it should launch the Robocode software. The Robocode software for me has launched in a different window, so let me drag that over here. And this is what Robocode looks like. So we just saw a very short battle from two of the starter robots. Let's start our own new battle. The first thing I like to do before I start a battle is there's a really helpful option to turn on that sets the visible scan arcs. So to get there, I went to Options, Preferences, View Options, and then Visible Scan Arcs. I'll talk about what this does in a minute, but I think this is really helpful to understand how the code works. Okay, so to start a new battle, we go to Battle and New. There are lots and lots of robots that are pre-packaged with Robocode that help you understand how Robocode works and also give you some enemies to compete against as you're writing your own code. In addition to all of the standard ones, I added Beep Boop, which is the current world champion. So as you're developing your robot, it's fun to play against some of these with known, obvious, simple behavior. It's also really fun to compete against the world champion and see how good Beep Boop is. So let's watch how good Beep Boop is. I will select that and add, and then let's also add Fire. So these are two robots. They're now in my battle, and I can click the Start Battle button, and we can watch them. So visible scan arcs turns on these little wedges that we see that show which directions the robots are facing. Without this, I personally have a little bit of trouble keeping track of the battles. So this is a Robocode battle. The battle is a turn-based battle simulation. The turns are running so quickly that it's a little bit hard to tell. But in any given turn, the robots are moving or firing or any of that. We can see here that Beep Boop is certainly winning. Each robot has a health, and the health is labeled right over the robot. And when a robot's health gets to 0, then they die. And it's whichever robot is left standing wins. By default, I think this runs 10 full games. So there is a little bit of randomness here based on the spawn and all that. So 10 full games can help you decide which one is actually better. You can always speed up the frame rate if this is taking too long. So let's make this go real fast. We are on game 10 now. Okay, and when you finish, you get a little pop-up that tells you the scores and survival and all that. So that's Robocode. The next thing I would like to do in this video is start running or writing our own robot. So to do that, I'm going to go into the Explorer in VS Code, and I'm going to make a new package. So inside of this robots folder, each of these folders is called a package, and the packages help us organize our robots. If you're one of my students, I have very specific instructions about how to add a robot. If you're not, you can be a little bit more loosey-goosey with this. So under robots, I'm going to create a new folder, And in Java, packages are usually lowercase. For my students, I want your folder name to be your name. So my name is Chris Jones, so it'll be like that. And then inside of that folder, we will create a new Java file, and this new Java file will represent your robot. So my file is going to be called chrisjones.java. So I want your robot to be named after you. This will help me when I'm grading and organizing our end of unit tournament. So to summarize, under robots, we've got a folder that represents the package, and then we've got our Java file here. So when you first open that file, VS Code should pre-populate it for you with the package name, and then it should also give you public class Chris Jones. We are going to extend, there's a robot class that's provided with Robocode that has a bunch of simple starter stuff in it. So I'm going to extend robot. And to do that, we need to do some imports. So import robocode.robot. Oops, I have an extra dot there. Okay, so here is how this code is structured. Usually when we're writing a new Java class, we do a public static void main. That's not how this is going to work. There is a Robocode runner that draws all the pictures on the screen and all that. If you add your robot to a battle, it will create a new object of this class, and then it will call the run method from that object. So I'm going to start by just writing public void run. This is the method that expects you to implement. There are two sections to this method. The first section is the setup section. This is stuff that you might do one time at the very beginning of the battle. One really good example of something you might do here is handle spawn randomness. So at the very beginning of the battle, you spawn to a random position in a random orientation. You might want to write some code here that gets you to go to the center of the ring, go to a corner, something like that, gets you to a known position and orientation. After that code is done, the next thing that will happen is you will enter a while true loop. Okay, so this code will run forever until you die. So this is after the initial spawn setup stuff happens. You'll enter this while true loop, and whatever's in here is going to go over and over and over again until eventually the program concludes. Let's start very, very simple. I'm going to write some code that goes forward and backwards so we can just see our robot moving. To go forward, the code is called ahead. You provide a distance, so let's say 100, and then let's go back, and you also provide a distance, let's say 100. Excuse me. So if you've got this working, let's go ahead and compile and run and see our robot in battle. This robot will obviously lose because it doesn't do anything other than just drive around. So let's see how that works. At this point, you should, for the rest of the time, be able to use this play button up at the top of the screen. So I'll click the play button. It will automatically compile it the way that I've set it up in VS Code for you. And then it will launch the Robocode program. So to test our robot, we will add a new battle. And look, there's my robot. So I'll add it, and let's see how quickly Beep Boop destroys me. So I'll start my battle. And ooh, this is too fast to see what's going on. So we can see my robot just driving forward and backwards. And Beep Boop really quickly finds it and attacks it. Okay, let's switch gears back to the slides and talk a little bit about what's going on with our robot and all the things that we can do. We just went through all of this. Okay, so here is a zoomed in drawing of what the robot represents or looks like. The robot is divided into three parts. It's a vehicle. That's the tank part that you can drive around. On top of the tank is a gun, and on top of the gun is a radar. The important thing to know about this mounting order is that when you turn the vehicle, everything turns with it. So if I tell the vehicle to turn to the right, the gun will also turn to the right, and the radar will also turn to the right. I can control the gun independently of the vehicle, and I can control the radar independently of the gun. But it's important to know that if you turn something lower in this stack, everything will go with it. There is a Boolean setting that you can use to turn that on and off if you'd rather have the gun stay oriented when you turn the vehicle. That's possible. We just made our first robot. So there's a whole bunch of methods that we can use to get the position and the orientation of the vehicle and of the gun. You can also get the width and the height of the battlefield because that might change depending on which tournament you enter. When you move your robot, we just talked about ahead and back, and now we know turn left and turn right. So you provide how many degrees you want to turn. There's also a function called stop. One important thing to note is that we are extending the robot class, and the robot class is a synchronous class with blocking functions. So you can only execute one function at a time, and one function might take many turns. So for example, if I call the ahead function and I tell it to travel 100 units, it takes 18 turns to do that. So that's 18 turns where I can't do anything else. As you start getting deeper into Robocode, you'll notice that this is a major constraint that requires some pretty clever programming. If you're not one of my students, you might want to know about another Robocode robot that you can extend called Advanced Robot. Advanced Robot allows asynchronous commands so that you can be, say, turning and moving and firing all at the same time. For my students, I'm restricting us to just robot, not Advanced Robot. So we'll have to deal with the fact that you can only do one thing at a time. We also have some functions that control the gun. One thing to know is when you fire the gun, you have to specify a power, and we'll talk about power a little bit more. And then there's also functions for moving the radar, and those can go left and right. The next thing to know is that Robocode uses what we call event-driven programming. If you've studied any other interactive programming, you've probably seen this before. One really popular place where you might know event-driven programming is from JavaScript when we use like on-page load or on-document ready. These are events that happen as a website is being loaded that you can respond to. In other languages, in Python, you might know like Pygame uses events to react to when the user clicks on the screen or something. So these are events that might happen as the game is going on. I'll show you an example in a second of on-scanned robot. This is as your radar is moving around. If it happens to scan a robot, we can react to that. Before we do that, though, let's talk about physics. So there's a whole documentation online about physics in the Robocode game. The important thing that you need to know is that we're sitting on a battlefield that corresponds to the first quadrant in the coordinate plane. So 0, 0 is at the bottom left of our battlefield. And then you can get, we talked about those functions you can use to get the width and the height of the battlefield as well. There's no way to manually control acceleration and deceleration. There is a constant acceleration rate that's documented in this in the link at the bottom of this page. And the way that it works is when you provide how far you want to go, your robot constantly accelerates until it gets to the halfway point, and then it constantly decelerates until it stops. So you'll notice that if you want to be traveling really fast, you should provide a high number for your ahead function, knowing that that's going to block you for longer, but your max velocity during that will be higher. The other big thing you need to know is about firing the gun. So when you're firing the gun, you have to choose how much power to put behind the bullet. Bullets with more power will obviously do more damage, and they will also travel slower. Think of it like a force equals mass times acceleration. It's a bullet with more mass, and so it will accelerate more slowly. The other thing to know is that when you fire the gun, it generates heat. The more power you put behind the gun, the more heat it generates, and there's a constant cool down rate when your gun is fired, and you can't fire again until it's all the way cooled back down. So a very powerful shot will mean more cooldown time before you can fire again. There's a lot of strategy that goes into this about saving your high power shots for times that you know you're very confident you're going to hit your target. Okay, so let's talk about some of these events. I'm going to switch back to VS Code now, and I'm going to add the on-scanned robot event. So first, let's be able to see, let's do some scanning that'll let us see a robot. So I'm going to add a function here that will turn the gun. I'm going to turn gun left by, let's say, 180 degrees every time that I go forward. So now, remember when I turn the gun, the radar is mounted on it. So that means that I will sweep the radar 180 degrees in the field of view. And I'll be doing that every time I go forward and back. So after 2 repetitions, I'll have scanned the whole battlefield. So this is all our public void run function. Let's add another function called public void on scanned robot. This takes an input scanned robot event, and I'll call that E. And my VS Code automatically imported scanned robot event for us. If yours didn't, then you might want to check that out. So there's a lot that we can do here, but the important thing to know is this is what will happen. This code will run when we see a robot on our radar. You can do all kinds of interesting things from this scanned robot event. You can get information about what robot you scanned, where it is, its heading, all that kind of stuff. You can even sense its energy level. What we're going to do now is something really simple. We're just going to say if we ever see a robot, let's go ahead and shoot our gun. So I'm going to say fire, and I'm going to make a really light, simple, fast bullet so we can see it. So I have changed my Java code, so I'm going to go ahead and hit run. And remember, I already set it up for you. So when you do this, it will recompile your code. So I'll hit run. It should recompile it. It should relaunch. Here is the new Robocode, and my updated robot is already in there. So I can go to battle, new. Here's my new robot. And let me attack Sitting Duck. Sitting Duck is a good one to play with because it doesn't do anything. It just sits still and lets you attack it. So let's start battle. We can see my robot's going forward and backwards, and every time it goes forward and backwards, it is turning its gun. And we're seeing that as it sweeps the gun, the radar is sweeping with it. And every once in a while, when the radar goes around, it notices Sitting Duck is sitting there and it fires a bullet at it. So this is obviously a very boring battle to watch. I'm going to speed it up a little bit. And we'll see that over time, the energy from Sitting Duck goes down every time it gets hit, and it will eventually die. And here's the summary that says that I have defeated Sitting Duck. So that's it. If you followed all this and you got all of this running, then you are ready to run with Robocode. There is so much to read and so much strategy to follow. There's a really exciting world that you can dive into from here. So there are lots of interesting ideas of things that you can do with your robot. Some robots choose to stay near a wall or in a corner. Some will choose to follow their opponent around, and some will just kind of try to run around randomly. One interesting thing to think about is that there's a whole offense-defense strategy here. If your movement or attacking profiles are very predictable, then your opponent might be more likely to catch you. So some robots choose to move around very randomly to try and make their behavior unpredictable. The game of Robocode is all about guessing and checking. So as you're working, you'll want to make little changes and then run the code and try facing off against a bunch of different opponents to see what works against who. And there is a fantastic Robocode homepage that links to a wiki. The wiki has lots of very good detail, and I've found that people who are involved in Robocode are very good at documenting and sharing their ideas. So you'll find a huge wealth of knowledge to play with. So with all that, that's the end of this tutorial. I hope that you have a great time playing with Robocode. If you're one of my students, feel free to reach out to me if you have any questions or need help getting all this set up. I hope that you have a great time with this activity.